Welcome back. So we have been discussing about the instruction set and the different types of logical instructions. And next category which comes under this logical instruction is rotate instructions. 8085 microprocessor has some instructions to rotate or to shift the content of accumulator uh, towards left or right. That means each bit in the accumulator can be shifted either left or right to the next position. So now let us see some of the instructions used to rotate or shift the content of an accumulator. So the first instruction is RAL. RAL, that is the opcode, and there is no operand at all. It's again a single bit instruction. So here each bit of the accumulator is rotated towards left by one position through the carry. That means the D7th bit is placed in the carry flag and the carry flag is placed in the least significant position or D0. And in this operation only the carry flag is modified according to the D7th bit. So example for a rotate left instruction is RAL. Here in case of RAL, here the D7th bit or the 7th bit is shifted to the carry flag and carry flag is shifted to the D0th position. And next position is, now we are going to rotate towards left. D0th bit will shifted towards the first and the first one will shift towards 2, 2 to 3, 3 to 4 and 4 to 5, 5 to 6 and 6 to 7. So this is the way, that is why this is the left side and this is the right side. So when we move from right to left, that is why it is shifting towards or rotate towards left. So when we rotate towards left, the most significant bit will or the MSB will go into the carry flag and the carry flag, the bit in the carry flag is moved towards the D0th position. Example, in this case see here, initially before the execution of this instruction, if the bit position is 1 1 1 0 0 0 0 1. Now when we execute the instruction RAL, what happens is the 1 in and this position is shifted towards this one here, and this 0 is shifted to next position and this 0 to the next position, right? And this one will shift it to this position, this will shift it to this position, right? Any mistake here? Yes, sorry. See here once again here, and this one here, this will be here, this will be here, and this will be here. This one will go here, this one will go here, and this one will go here. And after that, if anything on the carry, that means this one, that is moving towards the last position, right here. So this is the carry is copied to this position. So after execution, we'll get a different pattern, right? This one, earlier it is 1 1 1 0 0 0 0 1. Now after execution, it becomes 1 1 0 0 0 0 1 0. Then the carry is the bit in the last position, or the D0th or D7th position is shifted to the carry flag. This is what happens in case of a RAL is. So one of the application of this RAL is, Say for example, initially if your bit is if your number is 4, then when you shift this towards left, then we can say or you can find the result from here also. Next instruction is RAR. RAR means rotate the content of accumulator right through carry. That means each bit of accumulator is rotated towards right, but by 1 unit, 1 position through the carry, right? RAR. That means D0th bit is placed in the carry flag and the carry flag is placed in the most significant part. I will show this one. Here, in this case, uh, just similar to the earlier one, that is RAL. Here we are using RAR. RAR means we are shifting the content of accumulator towards right. That means this content is shifted to this here, and this is shifted to this here. This is shifted to here, shifted to here, and this one here, this one here, and this the least significant bit is shifted to the carry flag, and the carry flag content of carry flag is shifted to the most significant or the D7th bit. This is D7 and this is D0. So they will get a result like this. Carry is set to 1 and 0 1 1 1. That means it is shifting towards right side, right? So that is RAR, right? So this is again a very important one. So we can use this one for many applications. Once again, RAR, it is rotate accumulator right through carry, and each binary bit of accumulator is rotated right by 1 position, and here again carry is modified to bit D according to the bit D0. Next is a circular shift, left shift, or RLC. Circular shift, left shift, and the instruction is RLC, and here the content of the accumulator is shifted towards left, right? Each binary bit of the accumulator is rotated to left by 1 position. That means D7th bit is placed in the D0 and as well as in the carry flag also. So that is the major difference between RAL and RLC. In case of RAL, D7th bit is copied to the carry, then the carry is copied to D0, and whereas in RLC, D7th is placed into the D0 as well as in the carry flag also. Now let us see one example here. Here we have the register. The content of register is like this. Now we are using the RLC register. That means all the contents are moving towards left, right? That means the content of this bit is copied to this here, and this is shifted to here, and this bit shift, all these are left. This is the left side, this is our left, right, and this is our right, right? So we are moving from right to left. So here, and this one is copied to here, and this will shift to, this one is shifted to this place, and this 0 is shifted to the D0th and also towards the carry also. Both sides we are copying this content. So the result will become, the 0 is copied here and everything is shifted by 1 unit. So we'll get the result like this. So this is what we call it as the RLCs. So again, so when you compare these two instructions, RLC and RAL, in case of RAL, we are copying the content of the 7th bit to carry, then carry to the D0. And whereas in RLC, the 7th bit is copied to both the carry and also to the D0th bit. So that is the difference between these two instructions. Okay. So RR is RRC, that is circular right shift. That is the next instruction. So here we will rotate the content of accumulator towards right. That is, each binary bit of accumulator is rotated right by 1 unit or 1 position. And D0 is placed in the position of D7 as well as in the carry flag also. Now let us see one example here. In this case, this is right, rotating towards right. So this is the left side, this is our left side, this is our right side. Now here, in this case, we will move the D0, D7 into next position. This one will move towards this, and this one will move towards this, and these are all moving towards the right. And also the last bit, that is D0th bit, is shifted towards the D7 and also towards the carry. So that is why we are moving from left to right. That is why this instruction is called as a rotate right instruction, and that is a circular right shift. So here, the after executing this instruction, we'll get a result like this, right? This one is copied to this position, so we'll get and 0 shifted to this one, right? See here the difference here, this 0 here, this one here, and this one here, this 0 here, and this is 1 here, and this 0 here, this one here, and this is again shifted to this position. So this is what we call it as RRC. So RAR will move, this is RAR will shift the content of register towards right through the carry, and whereas in RRC will content of the register will move towards carry and also towards the D0 bit. So these are the four different types of instructions available to rotate. So we'll call it as the rotate instruction. All these instructions are single byte or a 1 byte instruction. There is no operand at all. All the operations are affected towards or rotating using the content of the accumulator, and only the carry flag is modified according to these instructions, and all other flags are not affected. So let us summarize the different rotate instructions. So one, it is RLC, that is rotate the accumulator left, that means bit 7 goes to bit 0, and also carry flag, that is. And the next one is RAL, that is rotate accumulator left through carry, that means bit 7 goes to carry and carry goes to bit 0. And next is RRC, that is rotate accumulator right, that means circular right shift, bit 0 goes to bit 7 and to the carry flag. And RAR, that is the fourth one, that is rotate accumulator right through carry, that means bit 0 goes to the carry and carry goes to bit 7. So that's all about the different type of rotate instructions. Please do remember, these are all very important instructions, and it has a lot of applications. So that's all now. Thank you.